Alrighty, here we go. Welcome back to another Ohio State Test Standard Review. Today we're talking about Standard 8.NS.2, which mostly has to do with radicals and square roots and all that fun stuff. So, let's hop right in. Question 1. Match each expression to the range in which the value lies. And they give you three numbers. They give you radical 80, or the square root of 80, square root of 85, square root of 90. And they ask you, is it between 7 and 8, between 8 and 9, or between 9 and 10? So all you're going to do is you're going to go to your calculator, you're going to hit second, and you're going to hit this x square button right here. That gives you the square root. And if you're using one of the TI-32s that are in my room, it's still second x squared, even though your calculator looks different than mine. And you put in 80, and you hit enter. And it says 8.9442791. Is 8.9 between 7 and 8, 8 and 9, or 9 and 10? It's between 8 and 9. So you check that off. Now we're going to do the same thing for 85. Square root of 85 is 9.219544457. 9.2 is between 9 and 10. Now we know that the square root of 90 is going to be bigger than the square root of 85, so it will also be between 9 and 10. But just for fun, let's put it in. Wow, look at that. 9.48. That's it. All right. So let's go to question 2. An expression where x represents a whole number. Important thing to note, x has to be a whole number, is shown. The square root of 8 plus the square root of x. The value of the expression is between 4 and 5. What is a possible value of x? So here's what I'm going to recommend. Okay. Know your perfect squares. So we have 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, and 10 squared is 100. Okay, which means if you take the square root of 9, you would get 3. Okay, that's what perfect squares are. So first find out what the square root of 8 is. Square root of 8 is 2.8. Okay, so this needs to be between 4 and 5. Okay, so 2.8 plus the square root of x needs to be between 4 and 5. Okay? So what I'm going to do is I'm going to look at what perfect square can I use would produce a number that would stick us between 4 and 5. So what range does that have to be? It has to be a number that produces a square root between 1.2 and 2.2. Do we have any numbers that produce a square root of 1.2 or 2.2? We have something that falls in that range. The square root of 4 is 2. So let's put in 4 for x. And you can double check your work. Go into your calculator. Square root of 8 plus square root of 4. 4.8. Done. Okay? Just figure out what the square root is and figure out what whole number gets you into that range. Okay? The only whole number that gets you into the range of 1.2 to 2.2 is 2. Find out whatever perfect square you need to take the square root of to get to 2. In this case, it was 4. This one's a little more tricky. An expression is given that has a value between 4.4 and 4.5, where x represents an integer, and it gives you the square root of x plus the square root of x. What is the value of x? So, x has to represent an integer. So again, we're working with no decimals. Okay? So we have the square root of x plus the square root of x. So, in the same way that you would combine like terms in equation solving, where you would assume this has a coefficient of 1 and this has a coefficient of 1, you're going to just add your coefficients and keep your variable. So the square root of x plus the square root of x is equal to 2 times the square root of x. Okay? So now we have to divide our range by 2. Okay, so you can set this up as an inequality. 4.4 is less than 2 radical x, which is less than 4.5, and divide everything by 2. 4.4 divided by 2 is 2.2, is less than the square root of x. 4.5 divided by 2 would be 2.25. Yes? Double check. Always double check your work on tests. Good. So now we know that the square root of x has to fall between 2.2 and 2.25. So now we can just start madly plugging numbers in. The square root of 1. Because remember, we're only working with whole numbers here. 1. Doesn't work. Square root of 2. 1.414. Doesn't work. Square root of 3. 1.73. Doesn't work. Whoops. Not log. Square root of 4 is 2. Square root of 5. Square root of 5 is 2.23. Hold on a minute. 2.23 is bigger than 2.2 and less than 2.25. So our winner is the square root of 5. So x equals 5. Okay? All right. So let's go to our next question. An inequality is given where q is a whole number, and it says 1 over q is less than 1 over the square root of 17. Create an inequality to show all possible values of q. Okay, so we know that q is a whole number. That's important. So the first thing we want to do is we want to find the square root of 17. So let's just figure that out right now. The square root of 17 is 4.123. So 1 over q is less than 1 over 4.1. So remember, when you're working with denominators in fractions, as your denominator gets bigger, as the number on the bottom of the fraction gets bigger, your number gets smaller. So 1/4 is less than 1/3, right? 1/5 is less than 1/4. So if q needs to be a whole number, the next whole number up from 4.1 would be 5. So 1/5 would be less than 4.1. But however, 6, 7, 8 all works. 1/6 is less than 4.1. 1/7 is less than 1 over 4.1. So your answer is q is just greater than 5. Q is greater than 5. Any number or greater than or equal to, q is greater than or equal to 5. Or you could also put q is greater than 4. Could you? Yeah, you can put q is greater than 4. Either works. Because all values greater than 4 would make this statement true. So that's it. All right. The value of the square root of k lies between 2.2 and 2.3. Select all possible values of k. Select all. Select all. Select all. More than one right answer. You will get the occasional time where you don't have more than one right answer, but that is rare. If you see select all and you see check boxes, you are going to select more than one answer. Okay. All we're going to do is we're going to take the square root of each of these numbers and see what falls between 2.2 and 2.3. Square root of 1.49 is 1.22. Is that between 2.2 and 2.3? No. So we go to the next choice. The square root of 4.8. That's 2.19. That doesn't work. So we go to the square root of 5. That's 2.23. 2.23 is between 2.2 and 2.3, so you check it. The square root of 5.04. That's 2.24. That's still good. Check it. The square root of 5.3. That's 2.302. That is above 2.3. So you do not check it. And that means that the square root of 6 would also be too high. It is just these two answers. All right. Next question. Approximate the value of the square root of 23. Place it on the number line. Okay, so we're going to approximate the value by finding the square root of 23. The square root of 23 is 4.79. Okay? So look at how we're reading this number line. Here's 4, there's one extra dash, and 5. So we're going to have to assume that this is 4.5. Halfway between 4 and 5. So if you're approximating where the square root of 23 is, 4.79 would be about 3/4 of the way between 4 and 5. So you would have to want to try to put it about here, which is about halfway between 4.5 and 5. That's all you got to do. Just drag it, put it on the number line right there, call it a day. All right. So that's going to do it for this standard. I hope it has helped you. I understand some of these questions are a bit confusing, but I hope that we got you there. I'll be back for another standard. And until then, good luck on your state test.